In this section, we just discuss two things regarding variables. The types of variables that we have available in C, also referred to as storage classes, and the visibility to which variables can be restricted. And that we have a technical term for that called scope. So these are two different things, two different concepts. That there's some overlap between them because what storage class a certain variable belongs to or is of can affect what scope it has. So we're going to cover these two topics together. So there are four specific storage classes for variables in C. The one we've been using so far is the auto class. And you may have seen this label also, you may have noticed this label in the Visual Studio compiler as well in the watch window. It says auto or automatic over there. Another type of storage class is register. We haven't used this one and we will not in this course. A new one that we haven't used so far is extern or external, short for external. And finally, static, another one that we haven't used yet, but we will today. So, auto variables are basically local variables. So far, we've seen that when we created a variable in the main function, that variable was only visible while to the code in that function, in the main function. Similarly, when we created other variables in other functions, those variables were only available to us, accessible to us within those same functions. Variables like that are called local variables, and the corresponding name of the storage class is auto or making them automatic variables. Now, what storage class a variable belongs to determines how long that identifier, that variable exists, and like I said earlier, what its scope is. So some of these variables exist very temporarily while we are in certain sections of our program. Others may exist from the time that the program starts running all the way to when it terminates. A variable, or more generally an identifier's scope, is the part of the code where the identifier can be referenced, can be seen in a sense. So the variation of scope is such that some can be seen or can be referenced throughout the program, absolutely anywhere, while others are only available or can only be referenced in portions of a program. Now, linkage is a concept that we get to when we work when we have programs that span multiple source file programs. In that case, when you're compiling a program, what you need to do before that is, what you need to do in the process of compiling it, we have another step called linking. However, here we're going to discuss storage classes and the duration for which those identifiers or variables of those storage classes exist. And just like, yeah, so storage class specifiers can be split into those having automatic storage duration and those having static storage duration. Variables with automatic storage duration are created when the block in which they're defined, when we enter that block, they exist for as long as that block is active, and as soon as we exit that block, they're destroyed. So local variables are, of course, local variables can only be can only have an automatic storage duration. And an example of those are the local variables of a function that are declared in the parameter list of the function. We do not use the auto keyword for local variables because it is implied with local variables that are created. Local variables by default have an auto storage duration or an automatic storage duration. If you find the name automatic storage a little strange, it is because the variable is created when needed and it is cleaned up or deallocated or removed from memory when it is no longer needed. This is not something that you have to do manually. This is something that is taken care of for you. Now, among the static storage classes, these two subtypes, extern and static, both exist from the time that a program begins execution until it terminates. Static variables are allocated space in memory only once before the program begins execution. However, the difference between external and static identifiers is a difference of scope. Both exist from the start of the program until its termination. But external identifiers or variables can be accessed or can be referenced anywhere in the program. Static variables, however, not necessarily so. So, like I said, duration and scope are separate concepts. Now, variables, and this is actually the more commonly used term that you'll see. So variables specifically of storage class extern are called global variables. Global variables are created by putting them outside any function definition. Any variable placed outside of a function is a global variable. And you can access it, you can change it from anywhere in the program, from any function. That also makes it kind of dangerous. So just in general, note in general, you should avoid using global variables when possible. And it usually is possible. So, like I said, any function that is declared, that is after the declaration of a global variable in the same file, can access that global variable. Okay. So, like I already mentioned, as a general guideline, do not use global variables. Whenever possible, avoid them. The reason is, sure, they're accessible from everywhere, and that's the problem. They're accessible from everywhere. A function that is not supposed to make a change to a global variable can do so, even when it is by accident. So always try to avoid these. And if you have a variable that is or should only be used inside or by a particular function, well, that's right away a reason to make it a local variable. Should certainly not be a global or any kind of external variable. Now, some local variables inside a function are declared static. We haven't done that yet, so this will be new. Using the static keyword. What does that do? So for example, let's take this statement over here. Now this part we're kind of familiar with. We're already familiar with. This is just the declaration of an integer variable count and initialization to 1. However, put the static keyword in front of it, and what will happen is that sure, it'll declare the variable, but the variable will not be cleaned up, will not be removed after you finish executing the function. If you do not initialize a static variable to anything, it will be initialized to 0 by default. Now there are also other uses of the keywords extern and static, and those are covered in another chapter, chapter 14. If you're still not clear about what declaring a local variable static does, don't worry. This is a topic that will be easily understood by looking at the example code. So let's get to the other topic of today, the scope of an identifier. So put simply, the scope of an identifier is the portion of the program in which that identifier can be referenced, can be seen, in which it is visible. Now there are 4 scopes for identifiers. There's function scope, file scope, block scope, and function prototype scope. Now, uh, labels are basically identifiers followed by a colon, like this one, for example, uh, are the only identifiers with function scope. Labels can be used anywhere in a function in which they appear but cannot be seen or referenced outside that same function. And an example of that is is the use of labels in the switch statement for the case labels, and in go-to statements, which, like I said earlier, we will not be using. So, global variables and function definitions. So, where we specify what's the code inside the function, and function prototypes are all outside of any other functions, and all of these have what we call file scope. They're visible from anywhere within the same file. Identifiers, variables defined inside a block, have block scope. How do we specify a block? Well, blocks are specified by opening and closing curly braces. I'll show you an example of that. Local variables defined at the beginning of a function have block scope, same as function parameters. Both are considered local variables by that function. Now, any block may contain variable definitions, and we've kind of already seen an example of that when we were defining counter variables for for loops, for example. Those counter variables would cease existing as soon as we exit that for loop. That's because the scope of those counter variables in those examples was within the block of the for loop. So now I think we already saw that counter variables after we exited for loop, if they were defined in the for loop statement, would not be referenceable afterwards. And now you know why that is. The scope of those variables was within the block of the for loop. If you nest blocks, kind of just like if you nest loops, loops are also blocks. So if you have nested blocks, and you define some identifiers in the outer block, those identifiers will be hidden until the inner block terminates. Which means that as long as the inner block is executing, it sees the values of its own local identifiers, not the values of the same named identifiers outside that block. Again, this will be something we'll cover in the hands-on example for this section. Now, local variables that are declared static will also have block scope, but they will exist from the time that the program starts up. So in this case, as you can see, storage duration does not affect scope. So let me jump to our example. And in this example, we're going to have multiple variables x, all defined, all with the same name, but in different scopes of the program. And that will demonstrate both scope and storage classes. So let me jump to the example straight away, and instead of going through the textual description, you can read that on your own in the slides. Let me explain the same thing through the source code itself. So in this example, we have a main function, and in addition to that main function, we have three other functions. One is called useLocal, and useLocal is very much like the functions that we've seen before. It has a local variable inside, and that's it. Then we have two other functions, and those two are different. The second one is called useStaticLocal that you see over here, whose prototype you see over here. And the useStaticLocal function will demonstrate demonstrate the storage class of a static variable, static local variable. And finally, we have the useGlobal function, which demonstrates that you can truly access global variables. That global variables have a global scope, have file scope, and can be accessed from anywhere in the file. And following these three prototypes, you see this on line number 9, a yellow highlighted statement. And see, before the main function is defined, we are defining an integer variable x and initializing it to 1 outside of all functions. This is a global variable. This x, if there's no other variable x at the local level, can be accessed from any place in this file. That's why it has file scope. This variable will exist from the time that this program starts, to the time that it terminates. We then have a main function, and inside of that main function, the first thing we do on line 13 is we define another integer x and set and initialize it to 5. Now we have two variables x. The difference is, however, that the second variable is a local variable. So, meaning anytime I'm inside the main function and I talk or reference a variable x, I will be referencing this variable, not the global variable. That's because the local scope of this local integer x overrides the global variable. And that's what we do in the very next line, in the next statement on line 15. We have a printf statement that says local x in outer scope of main is, and then it prints out the value of x. Which x? This x, because this is the local variable x. I also talked about adding a new scope inside a function, and that's what we see happening over here from line 17 to line 21. And this is how we start and end this scope. And inside of that scope, you see I'm defining a third integer, also called x. This is also a local variable, but this local variable will be visible only, will only have scope of, will only be visible, referenceable inside the scope highlighted in yellow over here. And I have a printf statement over here that says local x in inner scope of main is, and prints out its value. That will be this x over here. So this should show up as 7. Finally, we exit this inner scope and we have another printf statement. Local x in outer scope of main is, and prints out a value of x. Which x are we talking about now? Are we talking about this one, or this one, or this one? Well, we are outside of this scope that we created over here, which means this x, poof, has gone away. The only x I can be talking about right now is this one, because it is local. It is inside the main function where this printf statement is. Let's now try these other functions over here. And I'm going to call use local, use static local, then use global, use local, use static local, and use global again. And finally, to demonstrate again, I'm going to print out print local x in main. Local x in main is, which x is that going to be? That is again going to be the value of x equal to 5. So what's happening inside these 3 other functions? Let's begin with the one we are most familiar with. Function use local. Inside use local, we begin by defining integer x again, but this time initializing it to 25. Now this x will be visible, is created every time we call use local, and has scope only inside the function in which it is defined. So meaning when I execute this printf statement following the definition of this local variable x, printf statement says local x in use local is bloop after entering use local. This will print out the current value 25. In the following statement, we increment that using the pre-increment operator, which means this x will go to 26. And in the following line, we have another printf statement saying local x in use local is, and this will print out the new value of x, which is now, at this point, 26, before exiting use local. So the scope of this local variable x, whose value starts as initialized to 25, overrides the scope of the global variable x, which is initialized to 1. We then have the function use static local, and in this one we define, this is something new again, we define an integer variable x and initialize it to 50, but this is a static variable. The thing about static variables, static local variables, is that they exist when the program starts running, which means it's already initialized to 50, and even after we exit this function, return from it, go back to main, this variable will continue to exist and retain its value. Which means the first time I get into use static local and initialize x to 50, this will print out local static x is blah blah on entering used static local. So the first time this will print out as 50. Then we increment it, goes to 51. And then we print out use, a local static x is blah blah on exiting use static local. And here it'll print out 51. Now that's, so far this is the same as the previous function we looked at, the use local function. But here's the difference. After we finish running this, complete running this function, and call it a second time, and go through these printf statements again, this first printf statement will print out 51, and the second one will print out 52, because making this variable, this local variable, a static variable will let us remember the last value we had in it, because its storage duration is the duration of the program. Finally, we have the use global function. And in this one, as you can see, we do not define any local variable. Instead, we go straight away to the printf statement and say global x is blah blah on entering use global. So which x are we talking about here? Which x are we trying to print out? Well, this is finally the global x that we had out here. Why? Because we have not defined any variable x inside use global. So that's the only x we can talk about, the only one we can reference. If it's not local, we must be talking about a global variable. We multiply x by 10 and then print out the new value of x. X was initialized to 1, so this should still be 1, and global x is still 1. If you run this whole program, and let's see, what are we doing in the main function? We're first calling use local. Use local will always produce the same output. For 25, it'll print out the value of x as 25, followed by 26. Then we call use static local. The first time we call it over here on line 26. It'll print out values of x 50 and then 51. Then we call use global for the first time. And that'll print out value of x as 1. Then we call use local again. And because this x in here is local in scope, has it's recreated, redefined the second time we call use local, it's going to print out 25 and 26 again. But then when we call use static local for the second time, these are all called for the first time, and over here they're all called for the second time. When we call use static local for the second time, it's already set at 51. We increment it and it becomes 52. So we'll see these two messages for 51 and 52 over here. And then we call use global again. It's not going to do much. It's just going to print out x equal to 1 again. Going to multiply it by 10, which will be, first time will be 1, then 10. Now this time it'll be 10 and 100. Yeah, sorry about that. Okay. When you run this program, this is the output you'll get. So in the outer scope, in the main method, first we print out the local x, it's 5. Then we have this, we defined this inner scope in which we had its another variable x, which we initialize to 7. And when we exit that, we print out the value of x again, which now references the main function's local variable x, which is still 5. We called useLocal, which was initialized to 25, incremented it, becomes 26. We called the useStaticLocal function, initialized x to 50, then incremented it, became 51. And let me jump ahead to the second time we call useStaticLocal. The first time, the value of x is still 51, the same we left it from the first call to useStaticLocal. And we increment it, and it becomes 52. For the useGlobal function, x starts at 1. This is the global variable x. You multiply it by 10, it becomes 10. The next time we come back, call the useGlobal function again. X is still 10. The global variable x is 10. We multiply it by another 10, it becomes 100. And after calling all these functions, we again print out the value of x in main, which is still 5.